Hey everyone, I'm just here for day 9 of Advent of Code. It was a fun problem to solve. I thought I'd just do an analysis of my solution. This one is an interesting one, particularly because this happens. This happens sometimes in Advent of Code where they actually give you the solution, and then it's just your job to kind of iterate over that solution and maybe refine it so that it works within some boundaries. Um, and so I thought that those are always cool. Like that actually happens in the real world, right? You're given some code and and the manager says this doesn't perform well, or some architect says, "Oh, I want it to do this instead of this," and your job is to kind of tweak it a little bit, right? So let's just get into it and talk about it. The idea is you're given these sensor inputs, and you want to be able to guess the next input, and then for part two, guess the previous input. So if you think about in this first line, these are obviously incrementing by 3, so the next one would be 18, the previous one would be -3, and so on and so forth. So you're just doing a series of numbers. You think about it's like a series problem. They actually give you a way to solve it, right? And so the idea is, can you implement the way that they solve it? And basically, what they say is, take the difference of each of the numbers, and then you create a new list, and you do that repeatedly until all of the numbers are 0. And then once you've done that, to get the next number, you go through this little algorithm where you add the bottom number here to this number to get A, and then you add this number to 15 to get B. That's like the gist of the algorithm. So you imagine what you're doing is you're doing this. You're doing differences on lists, and you're slowly working down, creating new lists until you get to a point where all of the values are 0, and then you can do some calculations on the edge of those to get to the solution. And so this is kind of stepping you through that process, right? And it does it for multiples of the test inputs, where again you're just filtering down. You can see these ones are more complex, where there's multiple steps, and you're still working, trying to figure out how you get from point A to point B, or I guess I should say get to the next element. And you just keep iterating until you get 0, and then you can do some summing here to get to the final answer, the next value in that sequence. So, what are the gotchas for this one? Obviously, for small values, you're only going down a few levels. For very large values or very complex sequences, these things could be very large. And one key technique that you can utilize when you're solving problems like this is to think about the values that you need to keep as you're iterating or recursing through your solution, right? So this is very common in dynamic programming. So yeah, a DP, you may think, oh, I need to keep a 2D array of all the values, when in reality you're only interested in the current values and the previous values. So instead of keeping a whole grid, which may contain a million elements, maybe you only need to keep the last 2 of them, and that or the current and previous 2, which now you're only keeping 100 elements, for example. You're only worried about 100 elements. This problem is actually the same. I don't actually know if you have to do this memory safe technique to solve the problem. You might just be able to do this, but I immediately saw it just because I've done the dynamic programming stuff before. And so it'd be something, if you're not familiar with it, might be good to research on how this works. But the way to think about it is, when you're solving the problem, you're actually only interested in these values right here, to get this solution. And so there's no need for you to keep track of all of the rest of this data. And what that means is it's fairly simple for you to just actually keep this in a list, as opposed to trying to keep a list of list, which is all these values right here. It's just a memory saving technique. You'll see it a lot, again, when you're doing dynamic programming, where they say, oh, the solution is, I don't know, n log n, but the memory space is n squared or something like that, right? And you're like, oh, okay, yeah, that's big. In this case, though, you can say, oh, the solution is still n log n, but the memory space is only, is constant, right? Because it's n, for example. Okay, so how does this look in... Oh, and I should say, once you get these values, the actual solution to the problem is just to sum up all of the next sequences. So, you go through this problem set and you get the next number here and add it to the next number here and add it to the next number here, and that's your solution to the problem, which for my input was this. So let's just look at how that looks in code really quick. You can see there's actually not a lot to it. So here's my find next, which is the part 1 solution. And then part 2 was the same, but you're just doing it on the opposite end. You're just saying find the previous solution, right? So how do you do that? In Rust, there is a Windows function that allows you to take an iterable, or think about it as a list, and you can just take like little pieces of it, and the window kind of like slides through it. To find those. So I just say Windows, I get the diffs, and I say the way that I get the diffs is create Windows 2, so create a window of 2s, and just collect the difference of them, right? So do the difference of the first versus the initial, and collect those into a vector. So now I have the diffs, which is like, if you're starting here, the diffs is right here. And then I can just check, and I can say, are all of the values equal to 0? And the simplest way to do that is just to sum them up, right? There are some potential ways to make this faster, right? Is you could just search through the array and say, and find the first value that's not 0, and then you have to continue. This felt like a very simple way for me to like describe what I'm trying to do here, so I just used that. But again, you could loop through all of them. I think there's an any function in Rust. I will have to look and see. It might be interesting to look. There may be an any where you could say like any not 0 and it would return true. That might be another way to do this. I know you can do it in like Haskell, right? As you can say, hey, I want you to find any that aren't 0, and if they aren't, then return an error. Anyway, so once you're at the bottom, right? So if you say, oh, if I found the bottom, then I can solve the problem. We'll talk about it in a second. But if you haven't, all you do is just, we're going to add the value to our list of endpoints, and then we're just going to call find next recursively, but this time on the diffs of those values, right? So if you think about what the algorithm is doing, I explained that really quick, but the idea is I'm going to start with these set of values, and I'm going to perform a bunch of diffs on them, and that's going to produce this. I'm going to check if they're 0, and if they're not, I'm going to add this value to my list of like lasts, right? The ones that I'm going to add up when I'm done. And then I'm going to recursively call the function again on this set right here. So then I'm going to do the same. I'm going to do the diffs here, and I'm going to get these values. And then I'm going to check if they're 0. And then I'm going to add this one to the end of the list, right? So I'm slowly collecting these values until I get down here where they're all 0s. And now, for the first solution, the easiest way is just to sum them up, right? The way that you get the last element is it turns out just to be the sum of all of the items in the list, right? So to get this value right here, you just add up all of these, which were the ones that I put in my vecdeq here. I used a vecdeq. You may not have to. My initial thinking was you'd be pushing and popping, but you didn't need to in the end of it. as I was going through it. So you could just use an actual vector or some kind of list here to just accumulate those. And then all you do, again, so once you found your 0th value, once you found the list that are all zeros, you can just return the sum of those lasts that you've been tracking. So these values right here to get to your answer. And then otherwise, you add the last value to your lasts and call find next again recursively, right? So you're just recursing down this thing until you get to zeros, and then you can add all of these up right here, which will give you this answer. So it wasn't that tough. And I didn't use nom in this one when I did my input parsing because it was actually pretty easy. It's really just a list of integers, and so I could fairly easily just say, hey, for each line, call split on space and turn them into isize and collect them. They were isizes. Note there are negative numbers. You don't see them here, but when I looked at my input the first time, it was very clear that some of the numbers were negative. So that could be a gotcha. Watch out for that. If maybe you're doing some other type of parsing, you may think, oh, I'm just looking for digits, but you would be interested in those negative numbers. I didn't run into that problem because I just thought, oh, this is easy enough. I can just parse and isize. No worries. Okay, so that was part 1. Part 2 is the same thing, but it just says, hey, can you, instead of guessing the next number, can you guess the previous number? And it's the algorithm is actually not different, except you're not taking the sums anymore. So you're still filtering down, right? So you're still saying, oh, I'm going to go down. I'm going to do the differences here, and then I'm going to do the differences here. I'm going to do the differences here. I'm going to do the difference here. And now you get a set of zeros. And so what you want to do at this point now, the algorithm is slightly different. Whereas before, there was a shortcut where you just kind of sum all these values up and you get what you need. Now you're trying to move back in time. And so if you think about what moving back is like, this previous number is equal to its next number minus the number below it. So 2 minus 0 is 2. And then you'd say 0 minus 2 is negative 2. 3 minus 2 is 5. Minus negative 2 is 5. And then 10 minus 5 is 5. And that gets you to your number. Okay, so you still only need, instead of those last values, you still only need these first values, if you noticed. And if you think about what you're doing here is you're actually folding, which, if you're not familiar with, is a way of saying, like, create an accumulator, some like value that you're going to track, and then recursively, or not recursively, but iteratively through the list, call some function on it that returns an update to the accumulator. That's what fold does at a really short level. You can, if you're new and don't know what fold is, Google folding. Haskell does it. It happens here in Rust. It's a pretty common thing to do on lists or arrays and things like that. But the idea is you can perform a function iteratively over each of these values, where the one of the inputs of that function are the result of calling that the first time. And so if you think about what you're doing here is you're going to have some accumulator where you start at, say, 0, and then you're going to do this value minus the accumulator, and now this is the accumulated value, and you're going to do this value minus the accumulator, and then you're going to do this value minus the accumulator, and so on and so forth until you get to 5 here. So how does that look in code? If you compare find next and find previous, they're actually the same, except I've labeled them firsts instead of lasts. But when you have gotten to the point where they're all zeros, instead of calling this sum function, we reverse the list. This is notably important because you're subtracting. And so you can't switch values when you're subtracting. So you need to make sure you're doing it in the right order, which happens to be the reverse order, right? So you can think about the way you're building the list is you're adding this to the list, then this, then this, then this, then this. But you want to iterate over it from here to here to here to here to here. So you want to go backwards, and so you call the reverse function. You could do this another way, right? Like I'm using a vectq, so you could potentially like add to the front and then pull from the back as you iterate over it. But it was simple enough to say, oh, I just need to do the reverse. And what the fold function takes is your initial value, which in our case is going to be 0, and then some function to operate on all of the values. And you get the accumulator, which for the first case is 0, and the current value in the iterator, which here is x. And again, what is the answer? How do you solve it for each particular piece? It's just x minus the accumulator, right? So if you look back in here, it's x minus the accumulator. And then for this value, it's x minus the accumulator, x minus the accumulator, x minus the accumulator, which produces this, right? So again, fold is a cool function. It's available in many languages, and this was a great way to do it. Obviously, you could do this by hand, right? As if you have the list, you could do a for loop where you're iterating over all the values and keeping track of it. But fold is a very common tool and a cool shortcut to solve those problems. So there you go. That was my solution in Rust. Again, not too difficult of a problem. They kind of give you the answer to how to solve it. And it's just, can you take the problem and their description of the implementation and turn it into code. So, and here was my things. And again, I still had to work out some bugs. I didn't realize I needed to reverse. At first, I wasn't getting the right answer. I'm like, oh, why is it not the right answer? And then I had to step through it and say, oh, you know what? I need to, if I'm doing this fold operation, I need to do it in reverse. So, that's a common practice in most real world examples, right? Is someone has some architect or mentor or someone has kind of given you a top down solution, or not top down, but like a high level solution, and you need to think about, okay, how do I actually put this into code? And then you have to work out the bugs to get it to work. So this is a fun problem, pretty easy to solve. There wasn't anything that you're just like, oh, I just straight up don't know what to do. Again, I was able to use some tools that Rust give you, like the windows over an iterator and the fold, to help kind of solve this problem in a more simple fashion. But if you understand basic coding, for loops and stuff like that, you could definitely come to a solution yourself with that respect. So these are always fun problems. Again, like yesterday's answer or solution, it's not always do I know some cool algorithm to solve the problem. That's what I like about Advent of Code, is they're actually teaching you like tools that you will often use in real life, right? So the previous day was, can I do some analysis on the data to come to some kind of aha moment? And today's was, can I take, some mentor or architect's solution, description of a solution, and implement that in code to solve the problem. And those are both real world things. Very cool to see them do that. I'm curious how you guys solved it. Maybe there's some better way to do this, like you looked at the problem and you said, oh, I don't need to do it the way that they do it. I can do it this way and solve the problem faster. Maybe there's like a mathematical solution to finding those. I know I do follow some math things, and I've seen before, like, you can actually, for some of these inputs, there's games where they say, hey, can you guess the next number for this? And you can actually use programs that will create a function that will make it so that any next value is a valid value. And so, they kind of do that tongue-in-cheek to say, like, these aren't always good, like, problems to solve, puzzles to solve. But this one was pretty clear in saying, hey, here's how I want you to solve it. And so anyway, I thought that was just a fun little aside. But there you go. Here is day 9. It was a lot of fun. Both parts were, not particularly hard. And once you'd solved part 1, there wasn't anything amazingly crazy to solve part 2. the code looks largely the same. There's even a potential to say like, hey, can I merge this two code? Maybe I'll have some fun trying to do that if I got some free time. But love to see your guys' input. Like I said, love to see any comments on how I could further improve this code. And we'll talk to you tomorrow for day 10.